Hi friends, welcome to our channel. This is Kishore Palavarsa. Please subscribe our channel for more videos as well as for more information. So please support me. I need your support. Okay. So please encourage to me. So I have to take the different types of makings of videos with your support. Okay. So now today we are going to discussing about generation of harmonics. Generation of harmonics. Okay. Generation of harmonics. Okay, so coming to the generation of harmonics. Okay, here first of all, what is the mean itself? Harmonics. Harmonics means simply you can say that the effect of change in pulse number. The effect of change in pulse number in that particular transmission line. So the transmission line means that is like either overhead transmission lines. For example, okay, we have to take the effect of change in pulses. So change in pulses or else also called as effect of change in frequency also. Anyway, we can say that. Okay, so the effect of change in frequency or else the effect of change in pulse number in that particular transmission line. In that particular transmission line is called as harmonics. Is called as harmonics. Please remember that, very important. Okay, as well as coming to the generation of harmonics. As well as coming to the generation of harmonics. So basically there are two types of harmonics is there. Basically there are two types of harmonics is there. According to the bridge is both balanced as well as unbalanced condition. According to the bridge is both balanced as well as unbalanced condition. Okay, here bridge means basically simply we can call it as like a load. Bridge means here like a load. Load means here consumer end. Load means here consumer end. Okay, keep that point, very important. Okay, so here, so according to the generation of harmonics, there are two types of harmonics. First one is the characteristics harmonics. One is the characteristics harmonics, very important. Okay, characteristics harmonics. And second one is the non-characteristics harmonics. And second one, take the different types of makings of videos with your support. Okay, so now today we are going to discussing about generation of harmonics. Okay, generation of harmonics. Okay, so coming to the generation of harmonics. Okay, here first of all, what is the mean itself? Harmonics. Harmonics means simply you can say that the effect of change in pulse number. The effect of change in pulse number in that particular transmission line. So the transmission line means that is like either overhead transmission lines. For example, okay, we have to take the effect of change in pulses. So change in pulses or else also called as effect of change in frequency also. Anyway, we can say that. Okay, so the effect of change in frequency or else the effect of change in pulse number in that particular transmission line. In that particular transmission line is called as harmonics. Is called as harmonics. Please remember that, very important. Okay, as well as coming to the generation of harmonics. So basically there are two types of harmonics is there. Basically there are two types of harmonics is there. According to the bridge is both balanced as well as unbalanced condition. According to the bridge is both balanced as well as unbalanced condition. Okay, here bridge means basically simply we can call it as like a load. Bridge means here like a load. Load means here consumer end. Load means here consumer end. Okay, keep that point, very important. Okay, so here, so according to the generation of harmonics, there are two types of harmonics. First one is the characteristics harmonics. One is the characteristics harmonics, very important. Okay, characteristics harmonics. And second one is the non-characteristics harmonics. Okay, non-characteristics harmonics. First one characteristics harmonics and second one is the non-characteristics harmonics. Okay, those are very important, which is influencing on that particular transmission line. Okay, so coming to the characteristics harmonics. So even if the bridge means here load, if the bridge is under balanced condition, if the bridge is under balanced condition, so here balanced condition means both three phase. Okay, so here we are going to discussing about, let us consider three phase transmission lines. Let us consider like a three phase transmission lines. Okay, so otherwise if you want to go for the HVDC links, we have to show that there is like a different types of links, already know that. So like a bipolar link or homopolar link or like a monopolar link. So we have to take either AC transmission lines or else we have to take as a either DC transmission lines also. So both different types of transmission lines, so basically occurring of a different types of harmonics, So what is that? So we are discussing now. Okay, there are different types is there. Okay, now we are going to discuss. Okay, so coming to the here characteristics harmonics, if the bridge is under balanced condition, all you know that. Okay, so here under bridge balanced condition, there are different types of harmonics group levels will be existing. That is like, so in this generally produces a even harmonics. In this characteristics harmonics under the bridge is balanced condition generally produces as a even harmonics. Very very important, keep this point. Okay, generally produces as a even harmonics. The even harmonics is generally like second group. Okay, like second group as well as like fourth group and sixth group as well as eighth group, like 10th group, like 12th group, etc. Two we can add in. So these are called as even harmonics, which is produced under the bridge are else called as load, which is under balanced condition, balanced condition generally produced as a both even harmonics. Okay, so as well as coming to the this harmonics, the harmonics levels can be so generally we have to calculate as, so here the H is equal to NP plus or minus 1. H is equal to NP plus or minus 1. Okay, so this is the formula for the calculation of harmonics. Okay, here H is the harmonics. Okay, here H is the harmonics and N is the integer. Here capital N is the integer value. Okay, integer value, as well as here P is also called as change in pulse number. Here P is also called as change in pulse, or else also called as effect of change in frequency. So that is given as P. So simply we can call it as change in pulse number. Okay, change in pulse number. So this is called as P. Okay, as well as here one is the constant value. This is the one is the constant value. So this is the formula for the harmonics. Okay, so under bridge is balanced condition, there are different types of even harmonics is there under, as well as, so coming to the at AC side, so basically the bridge is unbalanced condition, there are different types of harmonics is produced in that, basically produced as current harmonics. Okay, as well as, so coming to the non-characteristics harmonics. Okay, so this non-characteristics harmonics is basically produced the bridge is under unbalanced condition. Here bridge ante entama, actually bridge means like a load. Okay, so under unbalanced condition, so basically there are different types of harmonics will be producing. Under unbalanced condition, there are different types of harmonics levels will be producing. So so basically different types. So like third group, third, fifth group, and seventh group, and ninth group, and 11th group, and 13th group. We can add to the two values. From the one value to another value, we can add to the two values. Okay, so these are the different types of harmonics values is called as odd harmonics. These are different types of values is called as odd harmonics. Okay, so which is generally the odd harmonics which is produced under the bridge is under balanced condition. Generally produced as a odd harmonics. Okay, as well as, so under balanced condition, basically in AC ad side generally produced as a voltage. Basically when AC ad side generally produced as a voltage harmonics. Okay, in case of balanced condition produced as a current harmonics, under bridge balanced condition basically produced as a voltage harmonics. Here unbalanced condition means here the three phases at the dead end of the load, which is not properly equal to the 120 degrees phase shift apart. ఫేజ్ షిఫ్ట్ ఎఫర్ట్ నాట్ ఈక్వల్ టు, సో సేమ్ ఫేజ్ షిఫ్ట్ అనేవి ఉండవు అనమాట. ఓకేనా, ఉండవు అనమాట. అన్ఈక్వల్ phase displacement may be contains at the dead end means at the consumer ends. Okay, so that's why at that time, so simply you can call it as the bridge is unbalanced condition. At that condition there are different types of odd harmonics will be so occurring, third, fifth, seventh, ninth, 11th, 13th, like that. Okay, in these harmonics, all those harmonics, basically the most dangerous harmonics, basically the most dangerous harmonics is like third group, fifth group and seventh group, third group and fifth group and seventh group. These are the very most dangerous harmonics which is influence on that particular transmission line, which is influence on that particular transmission line. These are the very most dangerous. Okay, so these are the different types of harmonics. So due to that harmonics, due to that both characteristics harmonics as well as non-characteristics harmonics, means both even harmonics as well as odd harmonics, the resultant output power will be decreasing at the transmission line. The resultant output power will be decreasing at the, simply you can call it as load. At the load center, the total output power will be decreasing due to increasing of harmonics. If increasing the harmonics means itself, the total counting of reactive power will be increasing. The total counting of reactive power increasing. Due to increasing of reactive power, the efficiency of the transmission line will be decreasing, as well as the output power also will be automatically decreasing. Due to that, so we cannot reach to the future load demand. We cannot reach to the future load demand as well as present load demand of the consumers. Present load demand of the consumers. So these are the effect due to the resultant harmonics. As well as, so due to increasing of harmonic levels, due to that increasing of harmonics levels in that particular transmission lines. Increasing of harmonics levels means itself reactive power increasing. Due to increasing of reactive power, so whenever this supply which is so continuously which is feeding to the particular machinery means particularly load center itself, the load here means may contains basically like any different types of static machines also connected as well as dynamic machines also connected. So there are all those different types of electronic goods which is connected at the dead end of the load, So due to increasing of these harmonics, due to increasing of harmonics, resultant reactive power also increasing. So whenever the percentage of reactive power will be increasing, this percentage of reactive power, so it will be, so goes to the input of that particular machinery, both so dynamic machines as well as static machines. So if for example, if we want to connect to the like a induction machines at the dead end of the load, so when we are supply will be flowing to the entire transmission line, so with the reactive power, so whenever feeding to the reactive power to the input of the particular induction machines, then only so the induction machines windings, both armature windings as well as field windings may be heating. First of all, may be heating. So basically we are supply will be given to the armature winding of the induction motor. So when we are supply is given to the armature winding of the induction motor, the induction motor will be heat developed in the induction motor, mostly heavily heat developed. Due to that heat resultant, the winding may be burning. Certain time, duration of time, the winding may be burning. Okay, so at the same time, another cause is there, another cause of effect is there due to resultant harmonics. So the machinery, the dynamic machinery, the rotating machine, dynamic machine means the rotating machine of induction machines may be contain some unwanted noise due to heavy increasing of harmonics levels to the input of the motor, Okay, so that is the one of the drawback. So if you want to, for example, go for the like a, so any industrial areas, if you observe the motor, if suppose the motor will be rotating like this, Okay, if you observe this, the motor may contains any unwanted noise. With the whenever the rotating. So you can simply say that the motor may contains, the input of the motor may contains, the harmonic levels will be increasing. The harmonic levels means the reactive power percentage will be increasing when compared to the active power. You can simply say that. Okay, so that is the meaning itself. Okay, so the motor may contains unwanted noise. Simply you can say that the motor inlet may contains the percentage of reactive power will be increasing. So basically the percentage of reactive power will be very low when compared to the active power. Then only the system is the healthy system. Okay, so this is the total due to the different types of effects for the harmonics, as well as there are the different types of classifications of both characteristics harmonics as well as non-characteristics harmonics. Okay, so this is friend today our class. Okay, if you have any doubt, please put on the comment, I will give the reply. Okay, as well as please support to me, as well as please encourage to me. Okay, I need your support. Thank you very much. Thank you.